Hello everyone, my name is Ahmed Sartokur. I'm teaching assistant for hydromechanics course. Today I'm here to conduct our first lab experiment. But before I start, I would like to mention some brief information about our experiment. If you look at your handouts, first page, you will see there is an objective and theory part in the beginning. Basically, the objective of this experiment is to determine minor and major head losses through this system of pipes.
Okay, now let's talk about a bit third part of the experiment. Characteristics of a fluid can be decided based on its Reynolds number. As you know, if Reynolds number of a fluid is less than 2100, it is considered as laminar. If it is more than 4000, it is considered as turbulent flow. In our handout, there is a formula given us to calculate Reynolds number. It is here, as you can see. In this formula, density, which is rho, velocity, which is v, diameter of the pipe, which is d, and the viscosity of the fluid is nu. In a steady flow, viscous effects can be incorporated into Bernoulli equation in terms of a head loss. What that means is that, basically, we can use Bernoulli equation to find major and minor head losses. Here you may ask, what is a major or minor head loss? Simply, losses happening in a pipe due to its surface roughness and length are considered as major head losses and shown as H major. Losses happening due to fittings, junctions, and elbows are considered as minor head losses and shown as H minor. Here you can see extended Bernoulli equation, and just below that we are given two more equations for major and minor head losses. Here, in these equations, F is the friction factor, L is the length of the pipe, and G is the gravitational acceleration, and K is the loss coefficient. When we go to the next page, you will see a Moody diagram is given to us. Once we calculate Reynolds number by using this formula, we can get friction factor by using this diagram, because we know that in this experiment we are using smooth pipes, so we will just need to follow this curve on the very bottom, or if it is laminar we are going to follow this curve. In general, the relationship between friction factor, Reynolds number, and pipe roughness can be estimated from the Moody diagram. When it comes to major losses, we have two different friction factor equations. If our Reynolds number is less than 2100, we are going to use the first equation. On the other hand, if it is more than 2100, which is stated as transition or turbulent pipe flow, we are going to use the second equation to calculate our friction factor. When we move on to minor head losses, we have two different scenarios. In the first scenario, we have bended and angled pipes. Here, if the radius of the bend is more than the pipe diameter, it is called pipe knee piece, and if it is less than the pipe diameter, it is called pipe bend. If you look at the first and second picture, you will see both of these situations. On the other hand, if two pipes are added one to another but didn't bend, it is called pipe angle, like in the third picture. In the second scenario, we have expanded and contracted pipes. The changes in cross-sectional area can cause discontinuous expansion or contraction. For a discontinuous change in cross-section, the loss coefficient, which is K, can be derived using the extended Bernoulli equation and the mass conservation principles. As you see from this formula, to calculate K-value for this continuous section. D2 stands for the larger diameter and D0 stands for the smaller diameter. We are going to be using these equations when you start writing your reports.
I want to continue with the setup descriptions. It's on page 4 in our manual. In here, I would like to introduce you our device before we conduct the experiment. If you look at bottom right side, you will see there are some numbers and names for the parts of our machine. Number 1 is called the pressure tapping labs. They are these parts, as you can see. This is where we are going to measure our exact heads during the experiment. Number 2 called ball cocks. These are these parts. I prefer them to call valves basically because it's way easier to remember. Number 3 is not important, it's just a backside wall. Number 4 is called double pressure gauge. We have one on the left and one on the right. We are going to use this part to read our heads during the experiment coming from these pressure tipping apples. Number 5 is the inlet. Inlet is the part where we are going to let water inside the system. And number 10 is drain, where we are going to let water outside the system. The number 6, 7, 8 and 9 are not related with this experiment. Now I would like to introduce you which section are going to be used for what. As you see, we have 1, 2, 3, 4, 5, 6 different sections, 6 different pipe sections. In this experiment, we are not going to use section 3, 4 and 6. We are going to use only section 1, 2 and 5. Section 1 are going to be used to determine head loss through a sudden expansion and sudden contraction. As you can see this by the sticker, these are thinner. Section 2 is going to be used to measure head loss through a long smooth pipe for a major head loss. Section 5 is going to be used to measure head loss through a 90-degree bend, 90-degree knee piece and 45-degree angle pipe. Before I start the experimentation, I would like to give you some brief information about what we are expecting from you to write in your reports. If you turn on page 7 in your handouts, you will see there is an analysis and report questions part. In the analysis part, we are expecting you to estimate some Reynolds number and comment on it if the flow is turbulent or laminar. We are expecting you to obtain friction factor or loss coefficient by using Bernoulli equation. We want you to, after that, estimate some friction factor and loss coefficients using the data measures, which I will send you by email. And then at the end, we wanted to plot the friction factor and Reynolds number graph. In report questions, you see there are several questions in this section. We want you to answer all of them in this part. Now I would like to continue with the experimentation part. Before I turn on the machine, I have to make sure that every valve is closed in the beginning. Then I will come here and start the device. Before we take some measurements, we have to make sure that all the air bubbles in the system are drained from the machine. To be able to do that, I will take these two hoses, which is connected to our pressure gauge, and put them in random pressure thermometers. Now, I will open this valve connected to section 1 pipe. You see water is coming inside. From here, when I open this valve, water will start to get out from the system. But of course, I also have to open this valve. You can see water is coming out now. To clear the air bubbles inside the system, several times I will close the valve and then open it again. You see bubbles are coming outside. I can also do it from here. After we finish cleaning the air inside the system, we can start our real experimentation. Now I put this bucket here. When I open this valve, water will come from this pipe, and when it reaches this level, I will stop recording the time, and we will see that is our delta T. Okay, let's start. 1, 2, 3. Okay, it's around 10 seconds.